Here we have a SAT math problem. Okay, let's go to the question. A quadratic function models the height in feet of an object above the ground in terms of the time in seconds after the object is launched off an elevated surface. The model indicates the object is ground 16 seconds after being launched. The object reaches its maximum height of 1296 feet above the ground 7 seconds after being launched. Based on the model, at what time after the object is launched in seconds does the object first reach a height of 972 feet? Okay, let's consider the given information one by one. Okay, the first information is a quadratic function models the height of the object which is launched from the ground, and the object hits the ground 16 seconds after being launched. And also the object reaches its maximum height of 1296 feet above the ground 7 seconds after being launched. Okay, based on this information, we have to find the time in seconds when the object reaches a height of 972 feet for the first time. Usually, we get a graph of a parabola for a quadratic function. For the given scenario, the graph of the quadratic function will be a vertical parabola. Okay, now let me draw the parabola over here. Okay, here I have drawn an horizontal line. The horizontal line represents the ground level, and here I have drawn a parabola because for any quadratic function, the parabola will be the graph. So for the given scenario, we get a vertical parabola which opens down. Okay, here this is the position at where the object is launched from the ground, and this is the position the object hits the ground. Okay, when the object hits the ground, the time is 16 seconds. So here we can consider the x coordinate as time and y coordinate as height. That is at 16 seconds it hits the ground. When the object hits the ground, the height is 0. And also, the object reaches its maximum height of 1296 feet above the ground 7 seconds after being launched. That is, when x is equal to 7, the object reaches its maximum height of 1296. Okay, here we have the maximum height. Okay, and also this is the vertex of the parabola. Okay, here when the object is launched, the time is 0 seconds, and also the height is also 0. Okay, now we have 3 points on the parabola. Since we have the vertex of the parabola, we can write the quadratic function in vertex form. That is y equals to a times x negative h the whole square positive k. Okay, here h is the x coordinate of the vertex and k is the y coordinate of the vertex. Then we get a times x negative. So here x coordinate of the vertex is 7. We can plug in 7 for h over here. And k is the y coordinate of the vertex. So that is 1296. Okay, our aim is to find the time in seconds when the object reaches a height of 972 feet for the first time. So we have to plug in this 972 for y over here and get the value of x, which gives the time. But in this quadratic function, there is an unknown constant a. So our first work is to get the value of this unknown constant a, so that we can plug in this value for y and get the value of x. How do we have to get the value of this unknown constant a? For that, we have to consider a point on the parabola. So that is, we can consider this point on the parabola 16, 0. So now we can plug in this point into this equation over here. So because we have this point on the parabola. Okay, now let me plug in this x coordinate 16 for x over here and y coordinate 0 for y over here. Okay, let me do it. So then I'm getting 0 equals to a times 16 negative 7 the whole square positive 1296. Okay, 0 equals to 16, negative 7 is 9. 9 square is 81. That is, we get 81a positive 1296. Okay, now let me subtract 1296 from both sides of this equation. Let me do it. Then this one will cancel out. On the left side, we get negative 1296. On the right side, we get 81a. Let me divide both sides of this equation by 81. Then this 81 will cancel out. Okay, here let me divide 1296 by 81. When I do so, I'm getting negative 16. That is, the value of this one is negative 16. On the right side, we get a. Okay, here I got the value of a. That is, a is negative 16. Now what we can do is I can plug in this value in negative 16 for a over here. Then the given quadratic function will become y equals to negative 16 times x negative 7 the whole square positive 1296. Okay, now the quadratic equation, the quadratic function is complete. What we can do is we can plug in this 972 for y over here and solve for x. Okay, let me do it. Equals to negative 16 times x negative 7 the whole square positive 1296. Okay, now let me subtract 1296 from both sides of this equation. When I do so, so this one will cancel out. When I simplify the stuff on the left side, I'm getting negative 324 equals to negative 16 times x negative 7 the whole square. Let me divide both sides of this equation by negative 16. That's negative 16 will cancel out. Negative sign will cancel out. Okay, now let me divide 324 by 16. When I do so, I'm getting 20.25. Okay, 20.25 equals to x negative 7 the whole square. Okay, for my convenience, let me write this one on the left side, that is x negative 7 the whole square, and write this one on the right side, that is 20.25. Now to get rid of the square, we have to take a square root on both sides. Okay, let me take square root on both sides of this equation. Then the square root and square will cancel out. Usually when we take square root on both sides of the equation, one of the square roots will cancel out, and for the other square root, we have to consider positive or negative sign. Okay, here we have x negative 7 on the right side, positive or negative. Okay, now let me find the value of square root of 20.25, that is 4.5. Okay, here positive or negative 4.5. Now we can split up this equation into two parts, that is x negative 7 equals to positive 4.5, and the other one is x negative 7 equals to negative 4.5. Okay, now let me add 7 to both sides of this equation. Negative 7 positive 7 will cancel out. I'm getting x equals to 11.5, and let me add 7 to both sides of this equation. Then this negative 7 positive 7 will cancel. I'm getting x equals to, when I simplify this one, I'm getting 2.5. Okay, here I got two values for x, and both of them are positive values. Okay, here the object reaches a height of 972 feet for two timings. One is at 2.5 seconds and other one is 11.5 seconds. Okay, here let's go to the graph, and here we have the value of x is 0. Okay, let me use a different color, sorry. Okay, here we have value 0 for x, and the value of x over here is 16. And we can take this value 2.5 over here, and we can take this value 11.5 over here. Let me write it clearly. Okay, now let's consider this height. Okay, let me. Okay, here when the time is 2.5 seconds, the object reaches a height of 972 feet. So we can write this point as 2.5 comma 972, and here also 11.5 comma the same height 972. So that is object reaches this height for two times. One is at 2.5 seconds and other one is around 0.5 seconds. But our aim is to find the time when the object reaches its height for the first time. Clearly, the object reaches height 972 feet for the first time at 2.5 seconds. So the answer for this question is 2.5 seconds.